Okay, today we're going to talk briefly about scalars, vectors, distance, and displacement. So a few definitions first. A scalar is a measured quantity that has no inherent direction. What that means is this is anything that you measure that does not have a direction attached to it, and it wouldn't make sense to attach a direction to it. So for example, mass or temperature, these things would be scalar quantities because it wouldn't make any sense to attach direction. For example, 50 kilograms, right? You would never say 50 kilograms north or 50 kilograms south. You would just say that something has a mass of 50 kilograms. A vector, by contrast, is a measured quantity that does have a specific direction. So there are examples of vectors that we'll encounter through the physics course through the year, but there are actually very few measurements that are vectors because they require a specific direction. Our first examples of scalars and vectors are distance and displacement. So distance is a scalar quantity measuring how far something has traveled along a path. And displacement is a vector measurement, and it shows us how far an object is from a specified point of origin to its ending point, and it must include direction. Okay, now displacement is a straight line measurement, therefore it will always have a specific direction. We'll show this through example. Position is simply an object's location where it is. So we often refer to displacement as a change in position. Right? We specify the change in position that occurs when an object moves from one place to another. We call that the displacement. So if an object were to start here at start and travel to the end, there are many ways for this object to do that. Right? It could start here and travel like this to the end, or it could start here and travel like this, or it could start here and go like that to the end. So all three of those paths would encompass different distances, right? The distance for this path would be measured by going all the way along the path and measuring how far we travel through the entire path. Right? So that is how the distance would be calculated. We would calculate the distance for this path by going from there to there to there to there to there to there. And notice in these wiggly, curvy paths, or even this jagged path, we are changing direction a lot, right? So we can't specify the direction for the distance. We can only tell how far it is we went. Now, if you want to talk about displacement, we need a much more specific way to show that. Okay. So this line right here would specify the displacement. And notice that this is a definite direction. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 boxes, right? So the displacement is 11 boxes. And we need to specify the direction somehow. Now, there are lots of different ways that we can specify direction here. We could just say simply to the right. If there happened to be a compass rose drawn on the page where that's north, then we could also say 11 boxes east. Okay. So that is really quickly and simply the difference between distance and displacement. So if an object traveled along this path from start to end, the distance and displacement would have the same amount or magnitude, right? So the magnitude of the displacement is 11 boxes. The direction for the displacement is to the right or east. The distance traveled, if an object were to go along that path, would be 11 boxes. So we could say that the distance could be the scalar part of displacement.